diving into some really interesting stuff today. A whole stack of information you've brought, and it all seems to point to this really urgent need for AI infrastructure solutions right now.
Yeah, and it seems like you've got a particular focus here too, specifically on telecom providers and SMEs and how they're going to navigate all of the complexities of this new digital landscape.
Exactly. And, that's what we're going to try to unpack in this deep dive, right? Why is this AI infrastructure so crucial for telecom and SMEs at this very moment? We're going to be looking at how much energy our current systems use, the role of AI in driving up that demand even further, and then the big question, can AI actually be the key to a more sustainable and efficient future, especially for these companies?
It's a bit of a paradox, isn't it?
Yeah.
AI is driving this huge increase in demand, but it also seems to be the best solution we have for managing it all.
Okay, so let's start with the basics then. I mean, it's clear from everything you've shared that our existing digital infrastructure is already struggling to keep up with, just the massive amount of data and constant connectivity that everybody wants these days.
Oh, absolutely. I mean, the demand for data and seamless connections is only going to increase. And as your sources show, this has a real environmental impact, mostly through the energy consumption and greenhouse gas emissions that come with it.
And the scale of it is just mind-boggling. Global data centers alone use somewhere between 240 and 340 terawatt hours of electricity in 2022. To put that in perspective, that's like the entire annual electricity consumption of a country like Thailand. And then you add in the energy needed to run the network infrastructure itself, all the transmission lines and base stations. And that's another 260 to 360 terawatt hours in the same year. We're talking about maybe 2 to 2.8% of all the electricity used worldwide just to power our digital lives.
And, a lot of this energy consumption is concentrated in just a few companies. The big tech players like Amazon, Microsoft, Google, and Meta, they saw their combined energy demands more than double between 2017 and 2021, reaching 72 terawatt hours. That just shows you the energy footprint of the services that so many telecom providers and SMEs depend on.
And it's not just a global issue either. If we look at the United States, for example, in 2023 data centers, they're used about 176 terawatt hours, which is already 4.4% of the country's total electricity consumption. And projections for the US are pretty worrying, potentially hitting 9% by 2030. For telecom companies with big data center operations in the US or SMEs that rely on cloud providers there, these trends could have a major impact on their costs.
Yeah, and all of this energy consumption, of course, leads to greenhouse gas emissions, especially when electricity is generated from fossil fuels. Data from 2020 suggests that data centers and transmission networks contributed roughly 1% of global energy-related greenhouse gas emissions. That's about 330 million tons of CO2 equivalent. It's a big environmental footprint, and both telecom providers and the SMEs they serve are becoming more and more aware of it.
But here's something I find interesting. The increase in energy use hasn't been as dramatic as you might expect. Between 2015 and 2022, despite a huge surge in internet traffic and data center activity, the rise in energy and emissions was actually fairly moderate. So what explains that?
That's a good point, and it really shows the progress that's been made in energy efficiency, both in data centers and network infrastructure. We've seen the development of more energy-efficient hardware advancements in cooling technologies and a focus on optimizing power use. Plus the increasing use of renewable energy sources by many ICT companies and the decarbonization of electricity grids in some areas has helped to slow down that growth. These efficiency gains are obviously good news for telecom providers who want to control their operational costs.
That's definitely positive. But it sounds like this period of relative stability might be coming to an end because of, all the advancements and rapid adoption of AI.
Yeah, you're right. The sources you've brought are pretty clear about this. Without widespread AI-driven efficiency solutions, we're probably looking at a significant surge in energy demands very soon. And it's mostly because of the huge amount of processing power that AI requires.
And the forecasts are pretty scary. The International Energy Agency expects global data center energy consumption to potentially double between 2022 and 2026. IDC also predicts a similar doubling to 857 terawatt hours between 2023 and 2028. And they specifically say AI workloads are the main reason Deloitte even predicts it could double again to approximately 1,065 terawatt hours by 2030. Even Goldman Sachs research is predicting a 50% increase by 2027 and a massive 165% jump by 2030 compared to 2023. That kind of growth has huge implications for the infrastructure that telecom providers need and that SMEs will increasingly have to use.
And the thing is, all these different projections basically agree. They all say that the growing demands of AI, like the huge computing power needed for training large language models, complex data analytics, and sophisticated AI applications, are going to put massive pressure on our digital infrastructure. This will probably lead to higher costs and sustainability challenges for both telecom operators and their SME customers.
And just like we talked about with the current infrastructure, a big increase in energy demand will likely mean higher carbon emissions, especially if we still rely a lot on fossil fuels for energy. The S&P Global Ratings projection of a 12% annual increase in U.S. data center power demand until 2030, potentially doubling the tech sector's carbon emissions, is pretty worrying. They say natural gas will probably be used to meet this demand, which could really slow down the progress on decarbonization that many telecom providers are working towards and that environmentally conscious SMEs want to see.
It's a big question for telecom providers and SMEs. How do they plan for these rising energy costs and the increasing focus on sustainability as they use more and more AI in their operations and services?
And it's not just the energy used to run AI that we have to think about. There are also emissions from manufacturing and deploying all the new data center hardware needed to handle these AI workloads. Things like producing concrete steel and all the specialized IT equipment. That's another big environmental impact.
Exactly. It's important to look at the whole life cycle. But this is where things get interesting. The same technology that's causing this increase in demand, AI, is also becoming a crucial part of the solution.
So there's some hope then. How can AI and automation help us deal with this potential energy crisis in our digital infrastructure?
Well, the sources show that AI-powered network management systems could save a lot of energy, especially in mobile networks. We're talking about potential reductions of up to 30%. And these AI systems are much more effective than traditional non-AI methods, often achieving 2 to 5 times greater savings. This is a big deal for telecom providers who manage these huge network infrastructures.
That's a really big difference. What makes AI so much better at managing energy consumption in networks?
It's because of AI's ability to process and analyze tons of real-time and historical network data. By finding patterns and trends that would be impossible for humans to see, AI can make very accurate predictions. This means we can have much more dynamic and efficient power management. Instead of using fixed shutdown schedules, AI can figure out when there will be low network demand, like overnight or during off-peak hours, and it can intelligently shut down certain network components. Then it can bring them back online right before demand increases again. It's like having a brain inside the network constantly optimizing everything.
And there are real examples of this in action. Ericsson's research suggests that using AI-powered monitoring and control can reduce energy use in the radio access network, which is a big part of a mobile network, by up to 12% every year. And it doesn't affect the quality of service. And Samsung's AI-powered energy saving manager, when used on Verizon's network, saved an average of 15% of energy, with peak savings as high as 35% during quieter periods. Those are big savings for telecom operators trying to reduce their energy bills and carbon footprint.
Exactly. For telecom providers who run and maintain these huge mobile networks, these energy efficiencies mean big reductions in operating costs and a much smaller environmental impact. And for the SMEs that use these networks every day, a more efficient infrastructure means more reliable service and maybe even lower connectivity costs in the long run.
So it's not just about managing power states. AI is also important for optimizing how resources are allocated in these infrastructures.
Yes, AI-driven automation can constantly analyze usage patterns and predict future demand for things like computing power, data storage, and network bandwidth. Yeah.
Yeah.
And it can do this all in real time. This allows us to allocate these resources much more intelligently, and it prevents over-provisioning, which is when we allocate more capacity than is actually needed. By right-sizing resource allocation based on predicted demand, AI helps to reduce wasted energy and resources. Imagine an SME that suddenly gets a lot of traffic to their website during a marketing campaign. AI in the cloud infrastructure can automatically increase the resources they need and then scale back down when the traffic goes back to normal. This prevents unnecessary energy use.
So we're moving away from a fixed one-size-fits-all approach to something much more flexible and responsive that adapts to what's actually needed.
Exactly. AI can also optimize how data flows within networks by intelligently managing bandwidth and traffic routing. This makes sure that data travels along the most efficient paths, minimizing congestion and reducing latency, which is really important for how well applications perform for both telecom providers and the SMEs they support. And AI-powered systems can automate a lot of the routine maintenance and operational tasks. This frees up IT staff to focus on more important things and could even reduce the energy used for manual interventions.
Now, data centers are huge energy users, and cooling them seems to use up a big chunk of that energy. How is AI making data center cooling more efficient?
Cooling is definitely a major energy drain in data centers, but AI is proving to be really effective at optimizing these systems. By analyzing lots of different environmental and operational data in the data center in real time, AI algorithms can adjust cooling parameters to match the actual heat load. This leads to much better energy efficiency. Google's DeepMind AI system famously reduced the energy needed for cooling their data centers by 40%. And Siemens' whitespace cooling optimization solution has shown average ongoing savings of 40% in cooling energy across different data center installations. These are huge savings for companies running big data centers, including many major telecom providers and the cloud providers that support so many SMEs.
40% is a huge amount. How can AI achieve such big savings in data center cooling?
AI algorithms can take in and process a huge amount of data from inside the data center. Everything from temperature readings across different server racks and airflow patterns to how well the cooling equipment is performing. By spotting small inefficiencies and correlations that humans might miss, AI can make very precise adjustments to the cooling systems. It can optimize fan speeds, chiller settings, and airflow to perfectly match the cooling needs at any given time, instead of relying on more general, less efficient settings. Plus, AI can be used for predictive maintenance on the cooling equipment, identifying potential problems before they cause breakdowns or inefficient operation. This saves even more energy and prevents expensive downtime.
So it's not just reacting to the current temperature, it's also predicting potential hot spots and adjusting the cooling to keep everything at the right temperature, using the least amount of energy.
Exactly. And aside from cooling, AI can also optimize the overall power usage within data centers by intelligently allocating computing resources and letting servers go into low power states when they're not busy. AI systems can also automate the control of other environmental factors in the data center, like humidity. This all contributes to overall energy efficiency. This kind of holistic approach to data center optimization using AI is really important for telecom companies that run their own data infrastructure and for the cloud service providers that so many SMEs rely on.
Another interesting application of AI is in predicting network traffic patterns. How does this help save energy?
By looking at historical network data, real-time conditions, and even things outside the network that might affect internet use like major news events or social media trends, AI can predict future traffic demands really accurately. This is super valuable for network operators, whether it's big telecom companies managing national infrastructure or smaller providers serving local SMEs. It means they can adjust network resources in advance of expected changes in demand. They can proactively scale down capacity when demand is predicted to be low, saving lots of energy. Then they can scale back up right before demand actually increases.
Makes sense. Why keep all the network systems running at full power if you know there's going to be a quiet period? It's like turning the lights off when you leave a room, but on a massive scale.
It's exactly. Sophisticated AI models can even keep network equipment in low power or sleep modes for longer by constantly improving their predictions. This leads to even bigger energy savings compared to traditional time-based schedules. The energy-saving wrap for Open RAN by NetReply is a good example of this in action. It uses machine learning algorithms to predict network load and automatically adjust the power state of individual components. This granular and dynamic resource allocation is crucial for optimizing both the performance and energy efficiency of telecom networks that serve lots of different users, including SMEs with different bandwidth needs.
It's good to see that these AI-powered solutions are actually being used. The sources you've shared show that a lot of companies and collaborative initiatives are actively implementing these technologies to make digital infrastructure more sustainable.
Absolutely. It's a definite trend. Nokia, for example, offers AI-powered energy management solutions specifically designed for mobile networks, and they're always developing more energy-efficient hardware and software. Samsung's AI ESM is already saving energy in real-world network deployments. Ericsson has also shown how much potential AI has to reduce energy use in radio access networks. Google's work with DeepMind for data center cooling is a well-known success story. Microsoft is using AI for intelligent network management and is looking into advanced cooling technologies along with their commitment to using renewable energy for their AI operations. Cisco offers AI-driven networking solutions that focus on energy efficiency. Meta is using AI a lot to optimize their huge data center infrastructure. Siemens provides AI-powered solutions for smart grids and for optimizing cooling in industrial and data center environments. And NetReply's work on developing AI-powered applications for making mobile networks more energy efficient, like the Ariane project, is another great example of innovation in this area.
And it's not just individual companies working on this. There are also collaborative efforts like the AI RAN Alliance, which focuses on integrating AI into radio access networks to improve performance and make them more energy efficient and sustainable. And the European Union is actively supporting green AI initiatives and funding research in this area.
These collaborative efforts, along with policies and regulations, are going to be crucial for speeding up the adoption of these sustainable AI solutions across the whole digital infrastructure ecosystem. Ultimately, everyone benefits from this, from the biggest telecom providers to the smallest SMEs that depend on this infrastructure for their connectivity and digital services.
So to sum it all up, we're facing some really big energy challenges with our current and future digital network infrastructure, and the growing demands of AI are a major factor. But the important thing is that AI isn't just making the problem worse. It's also giving us some incredibly powerful solutions to make these systems more efficient and sustainable.
It's exactly. And for telecom providers and SMEs, this isn't just some abstract environmental issue. Embracing and using AI-powered infrastructure solutions is a way for them to operate more efficiently, manage their resources better, and potentially save a lot of money in the long term. It's about making sure their businesses are ready for the future and can succeed in a world where AI is increasingly important.
It really makes you think, as AI becomes even more central to what telecom providers do and the digital capabilities of SMEs, what are the best and most innovative ways they can use these AI-powered infrastructure solutions? Not only to handle the growing demands on their networks and systems, but also to help build a more sustainable and environmentally responsible digital future for everyone. It's a big question for everyone to think about as we navigate this rapidly changing technological landscape.
Thanks for explaining all of this today.
You're welcome. It's been a pleasure discussing this with you.
Well, that's all the time we have for this deep dive.